Okay, so this is 8.5. So which grade is more likely to go to prom? At many high schools, the prom is an annual dance that only juniors and seniors can attend. The student council at a large high school is wondering if juniors or seniors are more likely to attend the prom. They take a random sample of 50 juniors and find that 28 are planning on attending the prom. An independent random sample of 45 seniors reveal that 29 are planning to attend. So, what is the point estimate for the proportion of planning on attending the prom? So for juniors, we have 28 out of 50, and that's going to give me 0.56. Okay, for seniors, we're going to have 29 out of 45, and that's going to give me 0.64. So the difference between these two, all we're going to do is just subtract 0.56 minus 0.64, and that's going to give me negative 0.08. Okay, so remember, they are asking for the difference between P1 minus P2, right? The juniors were listed first, and they're also wondering if juniors or seniors are more likely to go. Okay, so there's that. Construct and interpret a 95% confidence interval for the difference in proportions of juniors and seniors who are planning on attending the prom. So we've done this part before. So you're going to choose, check, calculate, and conclude. So choose, we're going to do a 2 sample. So last time we talked about a 1 sample. This time we're going to be talking about 2 sample Z interval for P1 minus P2. We're at a 95% confidence. Our parameter is P1 minus P2, and this is going to be the true difference in proportion of students planning to attend prom. The juniors minus the seniors. Okay. All right, now we're going to check. So you're going to check your random 10% large counts, and you've got to do it for both. So we're going to do random, and they're independent random samples. And again, that's so that we can generalize to both populations. So generalize to both pops. Okay. The 10% rule, you've got 50, which is less than or equal to 10% of all juniors. Okay, and even if we think about like our class size, juniors here at school, that's still about between 600 to like 900, right? And then 45 is less than or equal to 0.1 of all seniors. And remember, that can tell us that we can sample without replacement. We then have the large count, and that's going to be n times p and n times p minus 1. And you have to do that for both the juniors and the seniors. Okay, so I'm going to do this down here, but it really goes up here. I'm out of room and it looks sloppy. So 50 is less than or equal to, I'm sorry, 50 times 0.56, and these numbers are coming from up above, is equal to 28, which is greater than 10. And then 50 times 0.44 is equal to 22, which is greater than or equal to 10. And then you're going to do your seniors, which is 45 times 0.64, which equals 29. And then 45 times 0.36, and that gives me 21, which is greater than or equal to 10. So it works for all 4. And again, this is so that we can do an approximately normal distribution. Now we're going to calculate. The only difference between what we did on the last one and this one is that we're going to find the difference between the 2 points. So on here, the general formula is the same thing as last time. Okay, so nothing crazy different. Okay, so this is going to be point estimate plus or minus the margin of error Okay, now the specific formula. So this one's a little crazy, so bear with me. So P1 minus P2 plus or minus the critical value, habit, times the square root of P1 times 1 minus P1 over N1 plus P2 times 1 minus P2 divided by N2. Okay, so if we plug in all of our numbers into our equation, we're going to get negative 0.08 plus or minus 1.96. Remember that came from the inverse norm tomfoolery. We plug in the rest of this. So this is going to be 0.56. There we go. 0.56 times 0.44 over how many juniors? 50 plus 0.64 times 0.36 over 45. And we're going to plug all of that junk into our calculator. And when we do that, we're going to get negative 28 and 0.12. You're going to have a negative and you're going to have a positive on that one. Okay. Now, when we interpret our interval in context of the problem, and if I'm going too fast, go ahead and pause and like rewind, whatever you need to do. Okay. But interpreting your interval. So what you're going to do here is you're going to say that we are 95% confident that the interval from negative 0.28 to 0.12 captures the true difference in proportions of students planning to attend the prom. So the last question says, does the interval provide convincing evidence that juniors have a lower proportion planning on going to the prom, or is it plausible that there's no difference between the two classes? So it is plausible that there is no difference. And the reason why is because it contains 0. So if it contains 0, it could happen, but there is no difference. So there is, it is plausible. It is plausible that there is no difference because the interval contains 0. All right, flip over to the back. We're going to talk about summary. Okay, so biggest thing is we talked about the 4 C's, which we already talked about this, but we're just talking about it for proportions. So you're going to choose, check, calc, and conclude. And those are not new. Oh my gosh, those are terrible. Calculate and conclude. Okay. But evaluating a claim, that's the new part. So evaluating a claim. Okay. So if we have an interval that is a plus plus, then we have convincing evidence that first proportion is greater. If we have negative, negative, then we have convincing evidence that the first proportion is less than. If we have a negative and a plus, then there's going to be no convincing evidence. So there's no difference. Okay, so it's plausible that it could have no difference. Okay, all right, so you are going to try check your understanding. Remember, tomorrow we have a test, so make sure that you come prepared. See you tomorrow.